Hi everyone, I'm Priyavashni, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to talk about a very interesting topic, displays in augmented reality or AR. First, we know about augmented reality hardware, display, processor, tracking, and sensors. What is AR hardware means the system enabling augmented reality by overlaying the digital content onto the physical world. So the core components of the augmented reality hardware is in display, processors, tracking, and sensors. So the objective of the augmented reality hardware is to explore the functionality, requirement, and technologies of AR hardware. So the agenda is a display we give the visual, audio, haptic, and other sensories in processor role architecture and specifications. Upcoming videos we going to see about the processors and tracking and sensors. Okay, first now we are going to see about the display in AR. Display are the core technology that allows us to experience AR by blending the digital world with the real world. In this video, I will explain the role of the display in AR, the different types of displays, their requirements, characteristics, and even show you a real-time example. So let's get started. Okay, first slide we are role of the display. First, let's understand the role of the display in AR. The primary purpose of display in augmented reality is to deliver immersive sensory experiences. This is done by presenting digital content such as 3D models, animations, or information directly overlaid on the real world. For example, imagine looking at the street through your phone camera and seeing navigation arrows showing you which way to walk. This is the immersive AR display in action. But for this to feel real, the digital content must align both spatially and temporally with the physical environment. This process is called a registration, right? The spatial alignment means the digital object should appear exactly where it's supposed to be in the real world. For example, if you are placing the digital chair in the living room, it must stay fixed on the floor and not float away when you move on your phone. Okay, temporary alignment means the digital overlay should update in the real time without lag when you move your head or device, otherwise it feels unnatural and break immersion. So displays are not just about showing visuals, they are about perfectly blending digital with reality. Types of displays are visual display, audio display, haptic display, other sensory displays. Now let's look at the different types. So first is in visual display. These are the most common. They show images and graphics. Example include AR headset like a Microsoft HoloLens or smartphone based AR apps. Second is an audio display. AR is not only visual. Audio display enhance immersion using the spatial sound. For instance, if you hear footsteps approaching from the right side in a game, it feels like the sound is coming from your environment. Then is a haptic display. These involves the sense of touch. For example, special gloves or vibration feedback in controllers can make you feel as if you actually touching a digital object. So, and then is another sensory displays. This is an emerging area where technology simulates senses like a smell, olfactory display, or even temperature thermal display. Imagine wearing an AR headset that's let you smell coffee in a virtual cafe or feel warmth when standing near a digital campfire. Togetherness, these different type of displays make AR is a multi-sensory experiences of what beyond just visuals. Requirement of displays is for display to deliver a smooth AR experience, they must meet some strict requirements. High resolution so that the digital content look sharp and realistic. Low latency, so there is a no noticeable delay when moving your device or head. Next, FOV, that is wide flow of view. You can see more of the digital world without turning your head too much. Lightweight and ergonomic design so that the headsets or glasses can be worn comfortably for a long period. These factors together decide whether an AR experiences feel natural or distracting. Then characteristics of displays. Now let's go deeper into the technical characteristics of AR display. Most modern AR display aim for high resolution, sometimes up to 4K per eye, which makes digital object look almost real. They also provide a wide field of view, often greater than 100 degrees, which helps you feel surrounded by the digital elements instead of just looking through a small window. Another key feature is low latency, usually less than 20 milliseconds. If the display lags, your brain immediately notices the mismatch between what you can see and how you move, which can cause discomfort. But there is also challenges. One of the biggest is the vergence accommodation conflict, that is an VAC. Normally, when you look at a real object, your eyes coverage and focus are the same distance. But in AR, your eyes may coverage on digital object while actually display screen is different depth. This mismatch can cause eye strain and fatigue. If using for long period, solving BAC is still a big research area in AR technology. Finally, a real-time example. Let's look at a real-time example, the IKEA Place app. This app uses AR to let user visualize a furniture inside their homes. Imagine you want to buy a sofa but are not sure if it fits in your living room or not. Using the IKEA app, Place app, you can point your smartphone at the space and the app will overlay a digital 3D model of the sofa in real scale. This way you can walk around it, check if it matches your wall color and see how it fits with other furniture all before buying it. This is the great example for AR display at work. The app uses your phone's camera as a video see-through display and blends the digital sofa seamlessly with your real environment. In conclusion, so to summarize, display in AR are responsible for blending digital content with the real world. They come in different types: video, audio, haptic, and even sensory. To be effective, they must have high resolution, low latency, and ergonomic design. So, while AR display face challenges like eye strain from vergence accommodation conflict, they are already being used in apps like IKEA Place to solve the real world problems. That's all for today's video on display in AR. So thank you for watching. Thank you.